let's get on and do some maths. We're going to talk today about reducing balance depreciation. And this is another concept that comes from grade 11, something that they ask us about frequently in matric. So it's important that we are able to work with the reducing balance formula. Okay, so just a reminder again about the formulae that we already know. Let's just get a color here. So simple interest doesn't come up very often, especially not at matric level, but anyway, there's the formula. Compound interest we were talking about on Tuesday, where we were changing the compounding period. This is our formula A equals P1 plus I to the N. We all know that. This is another way that we can write the compound interest formula when we want to solve for P. Okay. Does anybody have any idea why the N would be negative? Does that make sense to anybody? Can anyone explain why that N is negative? What they've done is this. So they've said if Lorraine, go for it. Go for it.
Because depreciation means the like decrease in value of a product in over years, that's exactly why the N is negative, because its value is decreasing over a certain amount of years.
Okay, but this is compound interest. This is not depreciation, unfortunately. So this is compound interest. What's actually happened here is this. When we make P the subject, we divide both sides by the bracket. So in other words, A over 1 plus I to the power of N is equal to P. And then what we've done is that we have then taken that base, the 1 plus I as our base, into the numerator. And we have changed the sign of the exponent. So in other words, sorry, just rub that off. What's happened after this is we have written the A in the numerator. We've taken that base, 1 plus I, into the numerator, and we've changed the sign of the exponent. So it's actually got to do with exponent laws. Okay, more than anything else. Okay. The next thing is depreciation. That's what we're going to be talking about today. And there are two types. Either you can have straight line or linear depreciation, which also does not get asked very often. And then the important one, reducing balance depreciation. So reducing balance depreciation is like the opposite of compound interest. Okay, so again, we are looking at a curve, at a graph. So for example, here we can see the value of a car. So it starts off being worth 200,000 Rand, and after a period of time, it starts to lose its value. But you can see that it doesn't just become worthless. It doesn't just touch the x-axis after a period of time. How much value it loses starts off quite steeply, and then it sort of starts to even out after a while. Okay, that's why people always say it's a good idea never to buy a brand new car, because the person who's bought the brand new car, they're the one that lose the most. Okay, like in the first, I don't know, 3 years or so, that's where you've got the greatest decrease in value, and then after that it starts to level off. Okay, so that is reducing balance depreciation. So if they refer to it as reducing balance depreciation, you need to know which formula to use. The other formula that is from grade 11 that your teachers would have taught you in grade 11, and again it gets asked in grade 12 sometimes, is this one about nominal and effective interest rates. So we'll see if we can talk a little bit about that today. I'm not going to say too much about it right now because I just want to get into the reducing balance depreciation, but this formula over here is not on your formula sheet. The others are. together with your future value formula and your present value formula, but the effective and nominal interest rate formula is not given. So this one that's been highlighted in turquoise, if you want to answer a question on this, this needs to be learned. Okay, but we'll come back to that just now. Okay, so our reducing balance depreciation formula, A equals P1 minus A, 1 minus I to the power of N. All right, so here are our values. A is our book or scrap value. So it's what the item, I suppose item is maybe not the best word, what the car, the piece of machinery, the object, what it is worth after depreciation has taken place. All right, P is its present value. Okay, so it is the other way around to this. Here, in this situation with compound interest, A is always going to be bigger than P. Here, A is smaller than P. All right, that should make sense to you. Okay, so with reducing balance depreciation, A is smaller than P. The book or the scrap value is smaller than what the present value of the object is. I is our rate of depreciation divided by 100. And again, N is your time period. Now, if objects depreciated, and well, not if objects depreciated, when objects depreciate, if the interest is compounded more frequently than once a year, you can imagine a situation like this with the car. The car would be worthless very quickly. Okay, so when we are talking about money being invested, and the interest rate, or the rate of interest is compounded, then we are talking about something being able to grow frequently. But when it comes to depreciation, it only ever takes place on an annual basis. All right, so they are not going to compound more frequently than that, because as I was saying, what we own would be worthless very, very quickly. Excuse me. Excuse me. Sorry.
No,
Okay.
that's sorry, teacher Lee.
Yes.
Nazi, can you please switch off your camera? So Nazi is dedicated. She's bathing, but her camera is on. It's on.
Okay, that is
So,
dedication.
yeah, so I'm just
Okay,
asking her to switch off her camera.
that's
Please switch it off.
fine.
Thank you, girl.
Thanks,
Thank you.
Nazi. Cool. All right. So let's go and have a look at how we would use this formula. It's really very simple. I'm sure you guys are not going to find this difficult at all. So Josh wants to sell his car in 5 years' time. The rate of depreciation is 14% per annum, and the car's current value is 60,000 Rand. Calculate the book value of the car in 5 years' time if depreciation is based on, so A is the straight line method. I've crossed that one out. We're just going to look at B, the reducing balance method. So that's what they say, the reducing balance method. So you need to know that this is the formula to which they are referring. Okay, so if they ask us to calculate the book value of the car, they are telling us we need to calculate A. Right, that means the car's current value is the 60,000. So we would sub that in. The interest rate is 14%, and this is in 5 years' time. Okay, and we would pop that into our calculator. You guys can do it as well, and you can tell me what you get as an answer. Indeed, and I get the same answer. Okay, so after a period of 5 years, Josh's car is worth 28,225 Rand and 62 cents on the reducing balance method. Okay, so pretty straightforward. Everybody happy with that? Any questions? Well done, Boitumelo. Yamkela, that's interesting. Are you using the right formula? Because yours, Yamkela, that means that the car is going to be worth more in 5 years' time and not less. Okay, so are you subbing into A equals P1 minus I or 1 plus I? Okay, because it's not going to make sense for the car to be worth more in 5 years than it is currently. Yeah, Lesejo's right. Yes, Unwaba, that's it. Well done. Okay, fine. Give this one a try. So calculate, or we can, mind you, actually, this is working backwards. Maybe this is not fair. Let's rather do this one together. Calculate the original price of a computer if its depreciated value after 7 years is 900 Rand and the rate of depreciation was 12% per annum calculated. Let's try with a straight line balance, a straight line method first. So that's A equals P1 minus I N, like so. If they ask us to calculate the original price of the computer, what letter are they asking us to calculate? Exactly. Okay, so they want the P, right? So the 900 over here represents the which value? The 900 is the A, absolutely. So 900 is going to go over here. 1 minus I, so that's 0.12 times N, that would be 7. Okay, so what are you getting as your p-value? Matrix. That's it. Okay, so 5625. Well done. Okay, so that's if it depreciated on a straight line basis. Okay, if it depreciates according to the reducing balance method, then we have to use A equals P1 minus I to the power of N. Okay, so A will still be 900. Our interest rate is the same, it's still 12%. 7 is now our exponent. Okay, so now when we calculate the value of P, we would get 900 divided by 1 minus 0.12 to the power of 7. Cool, Luzuko and Ayanda. Nice, well done. Lesejo, good. Well done. So 2202, comma, 24. All right, so fairly straightforward. If you want to take screenshots, take screenshots. And we're going to move on to the next thing. When you say, why do the original prices differ? Okay, that's because the method of depreciation is different. Okay, so when we are talking about A, we are talking about straight line depreciation. So in other words, what's happening here is if these are your axes, your asset is depreciating like that. Okay, here in reducing balance depreciation, if those are your axes, then your asset is depreciating like that. That's why they're different. Okay, so the straight line method is a different method to the reducing balance method. That's why we get two different answers. So you can see when something depreciates, it's better for it to depreciate on a straight line basis because it loses its value slower than on the reducing balance method. Okay, does that make sense? Cool, Lazuko. Okay, so let's go and have a look at another question. I've got a picture of my calculator over here just in case we need it. A photocopy machine costs 40,000 Rand and has a scrap value of 8,000 Rand after 8 years. Find the annual rate of depreciation if it is calculated using A, the straight line method, and B, the reducing balance method. So again, we're going to do both methods in this particular question. All right, so let's have a look at part A first of all. So we've got A equals P 1 minus IN. And we've got to be very careful about which formula we select to use in financial maths, because if we use the wrong formula, we get absolutely no marks at all. Okay, so what is the P and what is the A? So we've got a 40,000 Rand here. We've got an 8,000 over here. What's the P? What's the A? That's right. Okay, well done, Mamelo and Ayanda. Good, and Nhlanhla, quite right. So your A value is 8,000. That's what the scrap value of the photocopy machine is worth. Okay, so it'll be worth 8,000 Rand after 8 years when it originally cost 40,000 Rand to buy. Okay, they want us to find the annual rate of depreciation. So when they say to us, find the annual rate of depreciation, what are they asking us to calculate? Exactly, they want us to calculate the I. All right, so we've got 1 minus I multiplied by, in this case, 8. Okay, so what's the next step? What do I need to do to both sides of my equation after this? Absolutely. I'm going to try and isolate that bracket. Okay, I want to isolate the bracket. Well done. So I'm going to divide by 40,000 on both sides. It's very important, guys, when you are doing financial maths, okay, do all your working on paper first, and then at the end you pick up your calculator. You don't pick up the calculator first. You must write first and calculate at the end. All right, so we've got 8,000. We need to divide that by 40,000, and that's going to be equal to 1 minus 8 times I. All right, what's the best thing for us to do in this case? If we want to solve for that I, that interest rate, what's the best thing to do now? I is 2. Okay, so different people are saying transposing. Absolutely, transpose the 1. Do you know what I think the best thing to do is? I disagree with you guys. I wouldn't transpose the 1. I would, exactly. Kumo, I agree. I would let I be positive. All right. Now, Rufense and Daka, you are saying use logs. Okay. Why are logs not applicable in this case? Why would we not use logs here? Okay, exactly. We're not looking for an exponent. We're not trying to find the value of an exponent. All right, so the easiest thing for you to do, guys, is, as Kumo said, transpose the negative 8i and make it positive 8i. That's going to be a lot better for you in the long run. Okay, so take the 8i to this side and take the 8,000 over 40,000. If you want to knock 3 zeros off there and 3 zeros off there, you can. You could even simplify it even further, but it doesn't matter. All right, and now we're almost there. What are we going to do to both sides? Remember, we want I on its own. So our next step would be to, there we go, divide both sides by 8. Well done. So this side must be divided by 8. That side must be divided by 8, and I would be equal to. Now you can pick up your calculator. Okay. Okay. Are you getting 0.1? Getting the same answer as me? Okay, good. Well done, everybody. There we go. Lovely. Okay, so we've calculated. We've calculated the rate. Lovely. Good. Okay, so now we're going to do the same thing, but we're going to use the reducing balance. Okay, the reducing balance method. Okay, so I'm just going to scooch over and create a bit of space here for us. Whoopsie, not too much space. We still want to see our question. Okay, so let's do it on a reducing balance now. Okay, so that means we see here it says reducing balance method. So we have to say A equals P1 minus I to the power of n. So remember again, we are calculating the rate of depreciation. We are calculating I. We've said that A is 8,000 and P is 40,000, so that's not going to change. 1 minus I, and in this case, the value of our exponent is going to be 8. Okay. So again, let me ask you, what's the first thing we want to do to both sides? What do we want to do to both sides? Good, lovely. Yes, we want to isolate those brackets and divide by 40,000. Good, so that gives us 8,000 over 40,000. And on this side, we cannot drop the brackets. Okay, on this side we could, because our exponent here, there was an invisible exponent of 1. We could drop the bracket and we could write 1 minus 8i. Here we can't, because 1 minus I is our base and 8 is our exponent. So the bracket has to stay. That's it, Ayanda. All right. So Ayanda's saying the 8th root, or root 8. Okay, so on your calculator, that's it, Gugu. On your calculator, You can see here's my calculator. This is what you want to do to get the 8th root. Okay, so let's try and use a bright color. It's this over here. Okay, that would be the button that we would use on the calculator eventually when we want to take the 8th root. Okay, we're not quite there yet, but absolutely. Okay, so let's take the 8th root on both sides. So we're going to do it on this side. We're going to do it on this side. And now we've got, the 8th root of, again, let's knock 3 zeros off and 3 zeros off just to make it a little more manageable. And that is equal to 1 minus I, like so. Again, what are we going to transpose? That's it, guys. Transpose the minus I. Okay. Transpose that minus I. It's just much easier for you in the long run. So your I goes to the left, and 1 minus the 8th root of 8 over 40 is now on the right-hand side. Now you're ready to pick up your calculator. Okay, and if, like me, you've got one of these sorts of Casios, you would activate this yellow function here by pressing Shift when you press that button. Okay, so Nhlanhla is getting 18,2. Nhlanhla, I'm going to check on my calculator what I'm getting as well. Okay, yeah, so for I'm getting 0,1822. I see a whole lot of you have put stuff into the chat. 3, 4, 5, 6, 6. Let's check what you guys are saying. Yes, there we go. Now remember, everybody, when you are calculating an interest rate, okay, we need 4, actually 5 decimal places, because remember, you're going to still multiply your answer by 100, okay, to get the rate R. Okay, so keep that number on your calculator, don't round it off, and now you're going to go press times 100. Now that number must be rounded to 2 decimal places. Okay, so you're going to end up with 18,22%. Okay, matrix. That's it. Well done. Okay, Mamelo, perfect. All right, so we've calculated A, we've calculated P, we've calculated I. We're also going to calculate N, but I'm going to do that on Tuesday with you. I'm going to do a lesson on logs and what they mean and when we use them and how to use them, etc., etc., etc. Okay, so I'm not going to do logs today. What I'd like to do is give us an opportunity to work through these questions. Okay, so I'd like you to try number 1, number 2, number 3, number 4, if possible, and then we can share our answers. So we'll start off with question 1A. I'm going to give you guys 5 minutes, and then we can share our answers for 1A and 1B. If you can either DM me or Yolanda, that's perfect, and then we can move on to the next one. Okay. Oh, yeah. Quite right. We certainly don't need to do number 3 then, for sure. Which one on Waba? So there's your one formula. There's your other one. Okay, so you guys get started. Not gonna worry about that one. Oh, how do you direct message me? So in the chat, instead of clicking on everyone, so look in the chat and then find me. Okay, so Lee, and then you can message me directly. Nice, Lesejo, good. You can go on to the next one. Good, Mamelo. Nice. Nonjabulo, lovely. Well done. Go on to the next question. Okay, Mamelo, let's just check. Okay, Lebogang. Okay, Luzuko. Good. Just remember to round to 2 decimal places, everybody. Okay, good. Well done. I'm going to start putting those answers up. You can carry on to question number 2 quickly. Yes, Lebogang, good. Nonjabulo, that's fine. Tari. Yes, just round carefully to 2 decimal places. Good, Yamkela. Good, Lorraine. Nice.
No.
Just check what's going on in the chat. Yes, that's looking good. Gugu. Which answer, Gugu? Yes, for both, Gugu. You are correct. Well done. I know some of us are on to question 2 already. Well done, everybody. Yolanda, no, that's not what I got. That's not what I got for 2A. All right, so for question 2A, they want the original price of the computer. Okay, so remember it's depreciated value, it's scrap value, it's book value is 1,200. I'm dropping hints here. For book value, let's say scrap value. Scrap value. Basically the idea is that it's yes, non-jabulo. Mamelo, that's not what I got for 2A. I did not get that answer. Non-jabulo, yes, that's the answer I got. Tuelo, I hope I pronounced that correctly. That's the same answer I got. Good, well done. Remember, we don't need to worry about number 3. And we can go on and do question 4 as well. Just check the chat. Okay, so yes, in other words, the book value is A, correct, Lasefo? Oh, good, Tuelo, I'm glad I pronounced it correctly. Normally I absolutely make a mess of those things. Okay, Gugu, yes for 2A, yes for 2B. Mamelo, quite right. Yamkela, no. Interestingly enough, you are getting the same answer, Yamkela, as who also sent me that answer? Can't see now. So, no, Yamkela, that's not correct. Yes, Boitumelo, good. Just don't forget about your decimal places. Lebogang, good. Lovely answers. Very nice. Everything's perfect. Ooh, Terry, no. No, no. Not for 2A. Norwazi, yes. Awami, that's correct. Lesejo. Yes, that's correct. Lesejo, your answer is correct. Twelve for 2B. Yes, I also got that. I didn't get the same decimal. Mine was slightly different. Ntokozo, okay, you're also getting the same answer as Yamkela for 2A. No, so something's going wrong in 2A and 2B. Ntokozo, Yamkela as well. Okay, so let's just do that quickly. The rest of you, if you're still busy, that's fine. Continue. All right, let's just look at 2A and 2B because there are some people not getting the correct answers. So if they ask us to calculate the original price of a computer, A equals P 1 minus I n, that would be the straight line method. The original price of the computer, you are calculating the value of P. So it of a computer, if its depreciated value after 5 years is 1200. So that 1200 is your A value. You are calculating P. So here you've got 1 minus its depreciation rate of 13%, and it is for 5 years. So that's what you should have written there. Then when you calculate the value of P, you're going to divide the 1200 by the bracket. Okay, so you should be getting P is equal to 3428. Those of you that are getting 420 as your answer, do you know where you've gone wrong? Awami, all your answers are perfect. Gugu, perfect. Tuelo, not the end of the world. Nolwazi, yes. Okay, so Yamkela for 2B. I know there were others who were also getting that one wrong as well. So reducing balance means A equals P 1 minus I to the power of N. So again, we have to calculate P. So we've got 1200 equals P 1 minus 0.13 to the power of 5. So when we calculate P, we are dividing 1200 by the bracket. Okay, so your P value should be 2407,60. Okay, Yamkela. You were calculating the P value. All right. Then I don't know exactly what went wrong there. On Waba, looking good. And when you say 4A and B, which question are you doing? Intercausal, okay, you see your mistake. Intercausal, A is always your end value. And P is always your starting value. Okay, so always, always, always. Okay, it's just when it comes to depreciation, something is worth a lot of money in the beginning and it's worth very little at the end. So that means that as far as your A and your P are concerned, with depreciation, okay, your end value A is smaller than your P. When it comes to compound interest or even simple interest, okay, your end value A is bigger than your P. Okay, so with depreciation, you were starting up here and you were ending down there. Okay, so your starting value is here at P, your ending value there is at A. A is smaller than P. With compound interest, it's the other way around. You're starting there and you're ending here. All right, so you're starting here with P and then you ending with A. Okay, A is bigger than P. Okay, Ntokozo? Okay, there's the answer for 2B there on the screen. It's a pleasure, Ntokozo, no problem. All right, and then as far as question 4 is concerned, again, they were asking you to calculate the original amount. For question 4, the book or the scrap value is 6,000 Rand. So that's your A value. So you would have said 6,000 equals P 1 minus 0.14, because it's 14% and 5 years ago. So when you calculate P, yes, Anthony, go for it. What's your question?
Hello, ma'am. Ma'am, may you
Hello.
please explain the graphs again, ma'am?
About the graphs.
Yes, ma'am.
With pleasure. With pleasure. No problem. So I'm just gonna work out the answer for number 4. So you should be getting 12,754 Rand and 37 cents for number 4. Just in case you were, yes, there we go. Good, Yamkela, you got it. And Awami, you also got it. Lovely, well done. Okay. So Anthony's just asked me to explain the graphs again. It's not a problem, okay, for me to do that. I think it's important for us to understand compound interest. We'll talk about mark allocation now. Gugu, normally with these sorts of things here, there would be these sort of calculations would not be considered that complicated as far as matric is concerned. So at matric level, there would be a mark for subbing in and a mark for the answer. Okay, with all of these, just a mark for subbing in and the answer. Okay, so it wouldn't be worth very much. When we're working with future value and present value and we sub in there, then it would be worth 3 marks. There would be a mark for subbing in, and then maybe getting your exponent correct, and then your answer. Okay. I think it's important, Anthony, and everybody else, to actually understand compound interest and depreciation using a graph. Okay, so as I was saying earlier, A is always your end value, and P is always your starting value. Okay, so that doesn't change. All right. What changes is which one is worth more, depending on whether something is depreciating. So if it is depreciating or depreciation, this means that it's losing value. It's worth less at the end than it was in the beginning. Okay, so if something has depreciated, its end value A is smaller than its starting value. So a graph describing reducing balance depreciation. So this would be reducing balance depreciation. Your object would start off up here, and then over a period of time, it would do that, like the car that I was talking about. Okay, so in the beginning, the car, its starting value, okay, is this P value over here. After it depreciates, sorry, this should be a straight line going back to the axis, it's now worth A, its scrap value. Okay, so your P is bigger than your A. Your P value is bigger than your A value. I hope that makes sense. With compound interest, it's the other way around. So for compound interest, okay, something is gaining value or increasing in value. Okay, so as far as your graph is concerned, it's doing that. Okay, or maybe that's not the best way to draw it. when it is an exponential function. After all, it doesn't really matter, but there you go. Okay, it's gaining value. Okay, so here, when we start off, there's our p-value. Right, by the time it's appreciated to a certain number of years, now it's worth A, whatever the case might be. Okay, so here your A value is bigger than your P value. Remember, on your y-axis, a number at the top will always be bigger than a number at the bottom. Okay, so this is compound interest. Okay, so I think it's very useful to think about it like that and understand it like that when we are doing the calculations. No one is ever going to ask you to draw these graphs. I'm just explaining it to you like that so that you have that additional understanding of it. Yes, yes, Latabo. That's exactly it. So if you think about it, it's generally things that we buy, like a car or a laptop or a cell phone or a fridge or a washing machine. All these things, when we buy them, they're worth a lot of money and they depreciate over a period of time. So if you now want to go and sell a TV secondhand, if you go into the shop and you buy the TV brand new from Macro, whatever, you're spending a lot of money. You're not going to sell it 5 years later for the same amount of money that you bought it for, because it has depreciated. It's lost value, like a car too. You know, you go out and buy a car for 100,000 Rand, and 10 years later, you're selling it for 50,000 Rand. Okay, depending on obviously on how you've looked after it and what car it is, etc., etc. Okay, so all these things that we have, they lose value as time goes on. All right, that's what's meant by depreciation. Okay, whereas if we save money and we put it in the bank, it earns interest. Okay, so it increases in value over time. Okay, so something like money saved in the bank is going to increase in value. Right. If you buy, I don't know, like some things that are like collector's items, you know, then maybe they would also appreciate in value over time, antiques, this sort of stuff. But I mean, those are obviously things that are going to be very, very expensive. All right. But it's generally what we're talking about is money in the bank when we're talking about compound interest. Okay. Does that make sense? That's it. Interest upon interest is compound interest. Good.